To close things out, I'd like to give you an example on how to bring all of these technologies together that we've been learning throughout the semester. With MySQL behind us, we now have a place to store data that is robust and that can grow into the future, that allows us to use enterprise standards on maintaining our data and making it accessible. However, this doesn't gel very well with the things that we learned in the previous unit, namely AJAX and JSON. What we're going to look at now is how to put a JSON layer in between the data and your web page. And then this will make it well suited to work with AJAX so that the data can seamlessly load into the page as we need it to. In the end, our PHP will be used to serve the data and to give us the JSON that we need. But it will not be used to make the web page. For that, we will stick with more traditional front-end technologies like HTML and JavaScript. With all of this together, it will feel nice and compartmented, where every language seems to serve the specific job it is best suited for. Now initially here, I've created one more database for us to access. This database contains the information that was used back in Unit 2 when we were experimenting with JSON and then with AJAX. It is a single table that has in it information about a customer. We will use this database to serve the data from MySQL. It is available in a database called People from the same server we've been working with all along and can be accessed by that same account that you've used before. Our goal today is to read this data in and then to render it separated across several pages, just like was done in assignment 2.4. What we'll be creating this time is often referred to as an API endpoint. This is a point on the server that we can use to retrieve data. When we access it, it won't really be giving us a web page in the traditional sense. This is very much like what we saw when we were working with AJAX, and we were reading data into the page while the page still existed, without having to refresh the page. However, this time around, it will be a true PHP endpoint, and at that endpoint, we will be reading data out of a database. We'll be giving it some options to customize that data as we read it out so that we only get a small portion of it at a time. We will learn a few new things along the way, but no new concepts need to be learned to do this. In fact, you know everything you need to know to do this right now. The things I'm going to show you in this lesson will simply show you how to do it a little bit easier. There are a few shortcuts that aren't too hard to use that will make this sort of a task smoother. So to begin with, our first thing that we want to do is be able to connect to that database and to pull out all of the people information from it. So let's go ahead and get our credentials put in and create a PHP page that we can access. I have a fresh example created here. This is started from the same base project that we've been using all along. I have the first page renamed to index.php, and I'm going to go ahead and create a brand new file. This will also be a PHP file. I'm going to put it in the same public folder. Let's call it peoplejson.php. This is going to be my data endpoint. It will be a PHP endpoint. And when I access this, it's going to give me data. Now to go through the process of getting data out of this, I need to simply connect to the server and go through the same basic steps that we learned in the previous lesson. So I'm going to go through those fairly quickly. However, a few of those steps will be modified slightly so that we can get the data into a JSON format a little bit easier. So previously I gave you these 5 steps for connecting to a database and retrieving data. We connect first, we prepare our query, we run our query, we bind variables to hold the results, and then we fetch those results, CPR, BF. So this is going to be more or less the same, except steps 4 and 5 will look just a little bit different when we do JSON. Now you actually could do it the exact same way, but if we do it slightly differently, life will be a little bit easier. So let's go ahead and get the basics out of the way, connecting and then designing the query itself. The credentials will be very similar to what we've used in the past, and I'll make sure that these are available right next to the video on the course website. So here we have the basics for connecting to the database. We basically are going to connect to the same host we have, we'll be using the same user, that same crazy password, and the new database we're going to be working with is called People. As always, we check for an error after we've tried to connect, and you'll see me using frequently now this function die. Die basically says, stop working and here's your dying words. Here's the last thing you're going to say. It will output that last message and then it will stop running right then and there. So it's fairly similar to a return statement that you might use in other functions when you're ready to stop. Now initially here I'm going to output connection error so that I can debug this and work with it. But eventually we're not going to want to do that. In the end, we'll want to make sure that anything we output actually could be interpreted as JSON, including any error situations. And so we'll deal with that once we actually get everything working and are feeling happy with it. For now, let's go ahead and save this, and let's bring it up over here. We'll have to navigate to it. People JSON. And when we do, we want to see nothing. And we do see nothing, so that's a sign that things are working correctly. Now, the particular query we're going to want to run with this, we will want to retrieve a certain subset of information from the table. But for now, let's go ahead and just take a look at what the basic info is that we might like to have for a person. We certainly would need their ID so that we could then retrieve more information later. First name, last name, and then let's also retrieve, how about city, state, and zip? Those are always pretty succinct. So first name, last name, and then city, state, and zip. So to get this, we'll build our query string first. So query is going to equal, this is obviously a select query, and we will say we want ID, first name, last name, city, state, and zip. And so this will get us everything except for their email, phone number, and street address. Now we don't want to grab everything because we want to have two stages here. In the first stage, we show people a sort of summary of all the entries that are in the table so that they could grab it again, or so that they can grab a specific one and ask for more detail on that particular entry. Now as we do this, we have to tell it where it's coming from. The table is named customer, and we're not really going to filter it at all. For now, we're going to just ask for everything. Now, eventually I'm going to show you how to reduce this down so that we're only getting a little bit of this information. But initially here, we'll just go ahead and grab everything. Now it's time to prepare the query. So we go back to our database connection that we created, and we're going to try and prepare it so that we can make a statement. Now as we do this, this particular function is going to return a statement. And so we'll set that equal to the statement variable, like we've done before. We then need to check whether or not an error occurred. And we do this by simply testing the statement function. If not, statement. When an error does occur, instead of returning a statement, it simply returns the Boolean value false. So this would evaluate to true, and we'd know that an error occurred. And so then we'll die with an error. Something to the effect of prepare error. All right, let's go ahead and keep going here. And everything still looks okay. Now the next thing we need to do, if we had any parameters in this, we would need to bind them so that they got properly sanitized and we would avoid any injection errors. In this case, we don't have any parameters. We're just grabbing everything. We aren't filtering it at all yet. So we're pretty much ready to run the query. So at this point, we can say statement execute. And we would put this inside of an if statement, if not execute, because it will return false if it fails. And then we would, again, show an error. We'll say execute error for now. Let's go ahead and save this. And everything still looks okay. Now is when we're going to deviate a little bit from what we've done in the past. At this point, we would normally then fetch all results and store them locally, and then look at how many were returned. We would then bind variables to all these different options, ID, first name, last name, and so on. And we would then fetch one at a time and go through a loop in order to process them all. Our goal here isn't to construct a page, but rather to simply convert this data into JSON and serve it. Anyone that accesses this page, peoplejson.php, should expect to get back JSON, not surprisingly. So we don't have to do as much to it. we can grab the data, and after executing a few simple functions on it, we should be able to spit it out in JSON format. So for this, we will in fact run a new function. It's called getResult. And so instead of storing the result so that we can iterate through it, we're going to actually get it. And this returns it as an actual object. And this is a new object that's part of the MySQL API that you could read about if you want to. The first thing we need to do, once you do this, you need to make sure that it actually succeeded. And there's two things we can check for that. So first we can say if not result, because just like before, if prepare failed, we would get back false. If get result fails, we could also get back false. So if not result, that would be our first basic check. And then the other thing we would want to check is if result num rows. We want to make sure that that is greater than 0. So actually, if it were less than 1, then that would be a bad thing. Then we would say die bad result. So this result object is going to contain a lot of useful things in it. We're going to focus on just a few key things that will allow us to get all of this data out of there without having to do as much work. Now, this will make it more difficult to access the individual values. So if we were trying to use those values to construct a page, this probably wouldn't be the best way to do it. We would stick with the normal store result, bind the variables, and then take the fetch approach, which was described in the previous module. Here, however, we basically have everything we need. Now that we've got the result object, we can go through and actually grab the individual rows from that result one at a time. We'll be able to do that in a real easy way. First of all, right here you can see we know how many rows are in it. So I can set a variable, I'll just call it rows, equals result num rows. Actually, there really isn't much point doing that. I've already got it as a variable. What I want to do is loop over this. So I'm going to create a variable, I, in a for loop, start it at 0, and make sure it is less than result num rows, and then we'll increment up. And then what I want to do is grab those rows one at a time. To do this, there's actually several different options that are available that are part of result. We can call fetch all, and that would actually grab all of the rows in an array and allow you to work with them. And it would be a numeric array, so you would go through it 0, 1, 2, 3, 4. That would be one way to work with this. You could also call fetch row, and that would grab you the data for one row, again as a numeric array. The one that we actually want to call is fetch associate. Assoc. This means fetch it as an associative array. Now that is not necessarily a term I've used before, but it's actually nothing different from what we've seen up to this point. In JavaScript and in PHP, the arrays we work with are actually associative arrays. We think of these as objects when we're working in languages like JavaScript and PHP, where there are keys and values. And every time you create a key, you store a value with it. Now, if it's a regular array, the keys are the integers and they're in order. They go 0, 1, 2, 3, 4. But if it's an associative array, the keys can be anything. Here in PHP, those keys will be strings, and they will be the names of the actual properties. So when we say fetch associative, the array will have as the key the name of the column for the data, which is really useful. So for example, ID, first name, last name, those will be the keys. And when you use that key, you'll get the value from that row. It's a really handy way to be able to go through it. It's more so handy because we can convert it to JSON with a single function call. So when we say fetch associate here, we will have our person data. So this will be data for one person, and we'll store that. What do we do then? We actually have a function, JSON encode. Not surprisingly, JSON is such a vital technology in all of this. PHP supports it out of the box. We give it an object, and just like that, it turns it into a JSON string that we can output, so that we can then say echo JSON encode person data, and we'll probably want a new line at the end of that, so I'll append that onto the echo. All right. This should go through and grab us all of our results, and it will loop through and get everything out of the result that we grabbed. The last thing we want to do is clean up a little bit. This is where we go through and everything that we worked with, we free it or close it. So we'll close the result, we will close the statement, and finally we'll close the database connection. All of these things need to be done just to make sure that we're not leaving behind any resources that we no longer need. Let's see what we get now. Oh, we've created an error. I'm going to guess it's probably a missing semicolon somewhere, but let's take a look and see. Let's go to the terminal. Parse error, we're expecting a parentheses, and where are we expecting it? On line 28. Oh, it's not a missing parentheses, it's the I right there. Must be that. Okay, let's see if that's happier. Hey, it is, look at that. So here's all of our data spit out for us in all its glory. For each person, we have their ID, first name, last name, city, state, and zip. And you'll notice that all of these are strings, and that's just how they're going to be. I guess the IDs are not. The IDs are actually integers. So there we go. This is all it really takes. And notice here, we did a little bit of less work in order to make that happen because we have this JSON encode function, and we can use that directly on the object that we get back from fetch associative. So that's why we would want to go this route when we're dealing with JSON. It makes life quite a bit easier. Now let's go ahead and shrink this back down because we're not done yet. We've done a few nice things here, but this is a lot of data. There are in fact 200 people in this database, and we probably don't want to be looking at all of that at once. Let's take a look at how we can actually use SQL to reduce the amount of data that it gives us back. We'd also like to make this look a little bit prettier. Right now you'll notice it's actually kind of rendering it exactly like it would render HTML, and that's because it doesn't know that it isn't HTML. So these are two things that we can take care of. We can let it know that it's HTML, or excuse me, that it's JSON, and we can reduce the amount of data that it's giving back to us. So in order to do that, we need some information. We need to know how much data do you want. So if we need to know information, that has to come in as a parameter. Parameters come into the server either through get or post parameters. We used post in the past because we were actually creating a post request. But this is not a post request. This is a get request. We are asking the server for something. So in this case, we're going to want to look for the data inside of the get array. There's two things we're going to need to know. We need to know which page we want and how many people there are per page. Now we did this before. In homework 2.4, you should have had to split this data into pages. And I believe we split it into 8 pages, which would mean that we had 50 people per page, right? Yeah, I think so. Or no, that wouldn't be 50 people per page. Let's say that we're going to do 40 people per page and see how that works out. I think that'll get us closer to it. This is something where we have a decent number of pages that we can work with. So in any case, we could actually, if the user simply tells us which page they're on and how many people there are per page, we can easily compute where we should start with these results and where we should stop. So let's try and grab that information. I would like to go in and get page as a value, and we'll get it out of the get array. Similarly, let's get page size and get that, again, out of the get array. And I'm going to do it, in fact, as all lowercase. Now, anytime we're accessing something like this out of the get or post or request arrays, we always want to make sure it's there before we try and access it. So I'm going to put in a test here. If isSet $get page, and actually let's put in a negative test. If not isSet get page, or not isSet $get, and then we had page size. So if either of those are not set, then something's wrong. We need to get back, or we need to not proceed in that case. So this would be a situation where we would die missing get params. is what we would want to do in that situation. So let's save this and let's see what we get now. There we go. It says missing get params. Now the nice thing about them being get is I can type them in right up here. Let's say we're on page 1, and like let's do a page size equal to 40 per page. Now we're not doing anything with that yet, but by providing those now it gets past this test and it gets into where we can start working with them. So we pull out those variables. How can we actually use those variables? Well, we need two things. First of all, we need to tell it how to limit the results. You can actually add that at the end of your query. You simply say limit and then the limit, how many you want to limit it to. In our case, that's going to be page size. In addition, we would want to tell it how far to go. Where it should start. So page size is going to limit the number of results we get back. But we also need to be able to tell it where to start. This is done with offset. Now we'll need to compute our offset. The offset is simply going to be equal to the page number times the size of the pages. So page times page size. However, keep in mind that if we're on page 1, really we're on page 0. If we were to do page times page size, when we're on page 1, it would in fact skip all of those values and go right to the first one on page 2. So if we do page minus 1, then we get the identity here for when it's page 1, 0 times page size, because it should start with item 0 when we're on page 1. And so we would then feed that in right here, offset. So we want to limit to page size, and then we want to offset by offset. By doing that, we can now get back fewer results. There we are. You can see here we stop at ID 40 now. Let's try going to page 2. Now it starts at ID 41 and goes to ID 80, and so on and so forth. Oops. Let's see here. I'll go to page 4, 121 to 160, and then we'll have a page 5, and that'll be the rest of them. Oh. This page is in Slovenian. No, it's not. Thank you, though. And then what if we go to page 6? Well, we just get a bad result, it says here. Really, what's happening here is that the number of rows is now less than 1. And basically, it's 0. We're getting back no rows at all because we went one page too far. Let's go back to, how about page 2? So there we go. It's just that easy then to limit our data and to change how much of it we get back, as well as to sort of move through it as if we're moving through in pages. So you can ask the user, what page are you on and how many are there per page? You've probably seen this before when you were going through searching in like a catalog for a store. Say you're over at Amazon and you're searching for things. As you go through the results that come back, you can often tell it how many you want to see per page, which is the page size, and then you can move through the pages by clicking on them. This interface with the database allows us to very quickly and easily reduce the data down to just what we need for one page. So now we have this data endpoint set up. The last thing we need to do is we need to make sure that it knows this is JSON. To do that, right up at the top of the page, we're going to want to, in fact, output something that is part of the HTTP response header. Keep in mind what we're constructing here, and it often feels like we're constructing a web page, right? Technically what we're constructing is an HTTP response, and the response will contain within it very often an HTML page of some sort. In fact, here it doesn't. It contains JSON data. We still have the standard structure of an HTTP response though, and at the very top we have what are called the headers. Inside the header we can set a different content type. To do that in PHP, you simply need to call header, and then we tell it what we want it to add into the header. In our case, we want context or content type, and then the type is application/JSON. And I believe it's a capital T here on type. It's very particular about this being exactly correct. Now, there's one other thing that's really important. You need to make sure that you call this before you've given any other output that might have been generated by a die command, for example, or by an echo, or by anything else that could potentially write to the quote-unquote web page. Once you've started writing to the body of the web page, you cannot go back and change the header. So make sure all header calls happen before any possible output. Line 7 here is our first possible line of output. So as long as we do this well before line 7, we're fine. Here we are indicating the data is JSON, not HTML, or the response body is JSON, not HTML. The interesting thing, when we do that, Chrome actually renders it differently. It recognizes like, oh, okay, this is not HTML, it's JSON. And so it switches to a nice equispaced font. Now, one last thing we need to do here, the format of this is actually not quite right. We would like to be able to format it so that what we are getting back out of it is in fact an array. Right now, it's just one object per line, and that's not proper JSON. JSON can only be one SQL object, not one object per line. We can just do this with a little bit of clever echoing. So initially here, let's echo out the array open, the square brace, and a new line. And then when we're all done, we'd want to echo out the same thing. And then in between each of these, we need to include a comma. Now this gets a little bit tricky. If I just echo a comma, and let's put a /n down there instead of up here, that will almost do it. If we save this and then refresh the page, let's look at what we got. There we go. So we're opening the array, and then we have one per line. Each one ends in a comma there. You can see after the closed curly brace, we've got a comma. The problem is right here. Oh, not to mention this too. I need to change the direction of my close array. There we go. Right here, the very last entry also has a comma after it. Now, newer versions of JavaScript are actually going to allow that. They will ignore it, and it's specifically because of situations like this, where we're outputting something, and we just like to do the same thing every time, and don't want to have to do something slightly different just for the last one. But the current versions of JSON do not support this. So we need to basically sense when we're at the last one, and only output this if we aren't at the last one. So we'll say if $i is less than result numbers -1. As long as it's less than that, then we're good. We should be outputting a comma. But as soon as it's equal to numbers -1, basically one value before it will break out of the loop, which is always the limit here, -1, then we need to stop and don't output a comma that time. Usually, for me, the rule of thumb is if I'm using strict less thans here, which I am in both of these cases, then I should be stopping one before, so subtract 1. If we save this and refresh, there we go. You can see now it just closes the array right at the end there with no comma, also without a new line, but that's fine. There we go. Everything in here now is ready to roll. The next thing that we want to be able to do is actually use this endpoint inside a web page somewhere. So we'll set up the web page and we'll use JavaScript to interrogate this using Ajax.